you would be explaining in detail about the if statement.
This is in this RTL we will see about the if statement. As we can see here, there are the inputs are clock, merge, AR, transmit, and FDDI, and the output is claim. And the output claim is a registered value. So in the if statement, generally what we will have is a multiplexer. See, since this is a procedural block in always statement, let's see the okay. The FCR here. FCR is equal to ER or XMIT. So here so although it is a procedural block which would infer a sequential logic, or it might be a sequential logic which are made up of latches and flip-flops, but it won't be having latches and flip-flops even though it is a procedural block which is used for sequential assignment. Why? Because the way the RTL is structured is the FCR output is equal to ER XOR X emit. So here this OR gate would be ER or sorry or X mid. The output will be going there. Then if merge is 1, if the value of merge is 1, it would is 1. So the value of claim, which is equal to FCR and FDD, which is AND of here what we get is an FCR and FDD. So if merge is 1, so this block will execute. If it is 1, it will execute. If merge is 0, then claim is FDI would be executing.
So as
See,
merge is the condition, it moves on to that, and then it works the same as whether that condition holds as true. So claim would take the values of FCR and FTDI.
yeah,
Else it would move to the claim having value of only FTDI.
yes, the important thing what we need to remember in this design is that the output is /1, but even though it is a procedural block having which is used mostly for modeling a sequential from the incompletely described case statement.
So all in all, this is fine, and we move to full case and parallel case. So the full case says what? Now the full case parallel case commands are two of the most abused synthesis directives employed by the Verilog synthesis design engineers. The reasons are what? Let's see. The full case parallel case makes the design smaller and faster. This full case also removes the latches from the designs, and then the parallel case removes the large slow priority encoders from the designs. And moving on to the above case, which may be just inaccurate or a little dangerous to understand or to implement. So let's see how. Sometimes these directives don't affect a design at all. Sometimes these things make a design slower and much larger to implement. And then sometimes these directive changes the functionality of the design. So these directives are always most dangerous when they work. So here, as they're talking about the reasons of using these synthesis directives, and then the dangers which are employed along with them. So what's your view about this?
There are some advantages and disadvantages, or pros and cons for applying a full case and a parallel case, and how it would be an advantages, it would be an advantage or a disadvantages. We would see in next slides. Yeah.
Well, we would be understanding all these points in detail later, and let's have a complete look on what is a full case statement. A full case statement is a statement in which all the possible case expression binary patterns can be matched to a case item or a case default. So it is important to note that if a case statement does not include a case default, and if it is possible to find a binary case expression that does not match any of the defined case items, then the case statement is not full. So it's basically introducing the concept of how it is full and why it is not full. So it's clearly understood from what the note says that if a case statement does not include a particular default case, then if it is possible to find a binary case expression that does not match it at all in any of the defined items as before the default statement, then it will not be full. So that means the default has to be there in a particular case statement. Only then we can call it as a full case statement. As according to me, I could understand, and of course, what is your view about this full case statement? Does it include something besides this to understand?
Yeah, we had seen in the previous slides that there are a latch is formed when incompletely specifying the case statement. We out of four binary input values, binary states, we just used two, right? So other two we didn't specify it, and neither we wrote any default value of any expression if it doesn't belongs to any of the
And what is it like? So this pertains to what exactly?
Yeah, as you told that it's a full case statement. It is a case statement where all the possible cases of the binary pattern can be matched to a case item or a case or to a case
So we
default.
do not have to really neglect any of these items or
Yes,
default case
yeah.
also.
Suppose you're taking a 2-bit value, 2-bit binary value 01. You are declaring that as a state expression, so it would be having a 4 possible case items. If you are declaring all the 4 possible case items, then that would be a full case. Rather, apart from that, if you are not declaring the 4 possible case items and you are declaring 2 and making a default statement, then it would be also a full case statement because you have declared a default value. So if 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 the condition won't be getting would be going on to any of the case items, it